Hey there, science fans! Welcome to another thrilling episode where we explore the wonders of chemistry. Today, we're diving into the fascinating world of acids, bases, and salts. These three types of chemical compounds are fundamental to understanding many chemical reactions. These chemical compounds are everywhere, playing vital roles in our daily lives and the world around us. From the food we eat to the cleaning products we use, acids, bases, and salts are integral to our everyday experiences. Ever tasted a lemon? That sour taste is due to citric acid. Acids are known for their sharp, tangy flavors and are present in many fruits and foods. Use soap to wash your hands? That's a base at work. Bases are essential in many cleaning products because they help break down oils and grease. Acids, bases, and salts are like the three musketeers of chemistry, always interacting and reacting. Their interactions can lead to fascinating chemical reactions that are both useful and essential in various fields. Acids are known for their sour taste and ability to turn blue litmus paper red. They are often found in foods and can be quite reactive. Bases, on the other hand, have a bitter taste and turn red litmus paper blue. They are commonly found in cleaning products and have a slippery feel. When acids and bases react, they neutralize each other, forming salts and water. This neutralization reaction is a fundamental concept in chemistry and has many practical applications. Salts are neutral substances, neither acidic nor basic. They are formed from the reaction of an acid and a base and are found in many everyday items. They are often found in nature as minerals and play essential roles in our bodies, such as regulating fluids and transmitting nerve impulses. Without salts, our bodies wouldn't function properly. Understanding acids, bases, and salts is key to unlocking many mysteries of chemistry. These compounds are the building blocks of countless reactions and processes. So, buckle up, science explorers. Get your safety goggles on and prepare for some hands-on learning. We're about to embark on an exciting journey into the world of acids, bases, and salts. This adventure will take us through their properties, reactions, and the science behind them. Get ready to learn about their properties, reactions, and the important roles they play in our everyday lives. From the kitchen to the lab, these compounds are everywhere, making our world a fascinating place. Let's start our chemical adventure with acids. These fascinating substances are all around us, playing crucial roles in both nature and industry. Remember that tart lemon we talked about? It's a perfect example of an acid in our everyday lives. That sour taste is a classic characteristic of acids. It's the citric acid in lemons that gives them their distinctive tang. But there's more to acids than just their taste. They have unique chemical properties that make them incredibly useful. Acids are substances that release hydrogen ions, H+, when dissolved in water. This release is what defines an acid. These hydrogen ions are what give acids their unique properties, such as their reactivity and ability to conduct electricity. Acids can be strong or weak depending on how many hydrogen ions they release. The more hydrogen ions, the stronger the acid. Strong acids, like hydrochloric acid, found in our stomachs, release a lot of hydrogen ions, making them highly reactive, while weak acids, like acetic acid, vinegar, release fewer. This makes them less reactive but still useful in many applications. One way to identify acids is by using indicators like litmus paper. These simple tools can tell us a lot about a substance. Acids turn blue litmus paper red, a quick and easy test to identify their presence. They also react with metals like zinc to produce hydrogen gas. This reaction is not only fascinating but also has practical applications. Think about what happens when you drop a piece of chalk, calcium carbonate, into vinegar, acetic acid. The reaction is immediate and visible. The fizzing you see is carbon dioxide gas being released. This is a classic example of an acid reacting with a carbonate. Acids are essential for many industrial and biological processes. They are indispensable in manufacturing and research. They are used to make fertilizers, batteries, and many other products that we rely on every day, and even our favorite sodas. The fizz and tang in sodas are due to the acids they contain. In our bodies, acids like hydrochloric acid help break down food in our stomachs. This is crucial for digestion and nutrient absorption. But remember, handling strong acids can be dangerous, so always wear proper safety gear. Safety first in all chemical adventures. Now let's move on to bases, the opposite of acids. Bases have a bitter taste and feel slippery to the touch. Think about the feeling of soap on your skin. That slipperiness is a characteristic of bases. Bases are substances that accept hydrogen ions, H+, when dissolved in water. they release hydroxide ions, OH, which neutralize the acidic hydrogen ions. Like acids, bases can be strong or weak. Strong bases, like sodium hydroxide, used in drain cleaners, are highly corrosive. Weak bases, like ammonia, found in cleaning products, are less reactive. Bases turn red litmus paper blue, indicating their alkaline nature. They also react with acids in a process called neutralization, which we'll discuss in detail later. Bases are just as important as acids in our daily lives. They are used in manufacturing soap, paper, and even baking soda. In our bodies, bases help neutralize excess acid and maintain a healthy pH balance. Now that we know a bit about acids and bases, how do we measure their strength? That's where the pH scale comes in. The pH scale measures how acidic or basic a solution is. The pH scale ranges from 0 to 14, with 7 being neutral. Solutions with a pH less than 7 are acidic, while solutions with a pH greater than 7 are basic, alkaline. The lower the pH, the stronger the acid. The higher the pH, the stronger the base. The pH scale is essential in many areas of science and everyday life. Farmers use it to monitor soil pH for optimal plant growth. Aquarium enthusiasts use it to maintain a healthy environment for their fish. Even our bodies rely on maintaining a specific pH balance for proper functioning. Section 5. Neutralization reaction. When acids and bases collide, get ready for an explosive reaction. When acids and bases come into contact, they create a fascinating and dynamic process. When acids and bases meet, they undergo a neutralization reaction, which is a fundamental concept in chemistry. It's like a chemical battle, where both sides end up neutralizing each other, resulting in a balanced and stable product. In a neutralization reaction, the hydrogen ions, or H+, from the acid combine with the hydroxide ions, or OH-, from the base, creating a new substance. This reaction produces water, H2O, and a salt, which are both neutral substances. The type of salt formed depends on the specific acid and base involved in the reaction. For example, when a strong acid like hydrochloric acid, HCl, reacts with a strong base like sodium hydroxide, NaOH, a common and well-known reaction occurs. They neutralize each other, forming water, H2O, and table salt, NaCl, which is a substance we use every day. So, HCl plus NaOH equals NaCl plus H2O. This simple equation represents a powerful and essential chemical process. Neutralization reactions are essential in many ways, impacting our daily lives and various industries. They are used in antacids to neutralize excess stomach acid, providing relief from indigestion and heartburn. They are also used in wastewater treatment to neutralize harmful acidic or basic substances, ensuring that the water released back into the environment is safe and clean. Section 6. The salty outcome, formation of salts. Remember the salt we talked about in neutralization reactions? Let's dive deeper into these fascinating compounds. Salts are ionic compounds formed by the reaction of an acid with a base. They consist of positively charged ions or cations from the base and negatively charged ions or anions from the acid. Table salt, which we use every day, is a classic example of a salt. It is formed by the reaction of hydrochloric acid with sodium hydroxide. Other examples of salts include baking soda, Epsom salt, and chalk. Salts play vital roles in various industries and our daily lives. They are used in food preservation, water softening, and manufacturing various products. In our bodies, salts help regulate fluid balance, transmit nerve impulses, and contract muscles. Section 7. Acids and metals, a reactive combo. Hold on tight because things are about to get reactive. When acids meet certain metals, they engage in a chemical reaction that releases hydrogen gas. This reaction is commonly observed with metals like zinc, magnesium, and iron. When these metals come into contact with an acid, they displace hydrogen from the acid, forming a salt and releasing hydrogen gas. For example, when zinc reacts with hydrochloric acid, zinc chloride and hydrogen gas are formed. This reaction is used in various applications, such as in the production of hydrogen gas and in metal cleaning processes. However, it's important to handle these reactions with care, as the release of hydrogen gas can be flammable. Section 8. Acids and carbonates. A fizzling reaction. Get ready for some fizzy fun. When acids react with carbonates, they produce a characteristic fizz due to the release of carbon dioxide gas. Carbonates are compounds containing the carbonate ion. When an acid is added to a carbonate, it reacts to form a salt, water, and carbon dioxide gas. For example, When hydrochloric acid reacts with calcium carbonate, it produces calcium chloride, water, and carbon dioxide. This reaction is responsible for the classic baking soda and vinegar volcano experiment. It's also used in antacids to neutralize excess stomach acid, as the carbon dioxide gas produced helps relieve bloating. Section 9. Acids, bases, and salts in our everyday lives. Acids, bases, and salts are everywhere. They're not just confined to chemistry labs, they play essential roles in our daily lives. From the food we eat to the products we use, these chemical compounds are constantly at work. Acids like citric acid add a tangy flavor to our favorite drinks. Bases like sodium bicarbonate help our cakes rise. Salts like table salt enhance the taste of our meals. Understanding acids, bases, and salts helps us make informed choices about the products we use and the foods we consume. It also allows us to appreciate the fascinating chemistry happening all around us. So there you have it, Science Explorers. We've journeyed through the world of acids, bases, and salts, uncovering their properties, reactions, and importance in our lives. Keep exploring, keep questioning, and keep that scientific spirit alive.